Hello and welcome to the next video in the unit. Today we're talking about linear regression. So it's just an extension of what we were doing the other day. Just now we're taking it one step further. So what is your goal today? I can use technology to obtain an algebraic model for a set of data using the concept of linear regression. So what is regression? Well, the definition of regression is as such. It's an analytic technique for determining the relationship between an independent and a dependent variable. So basically finding the equation of a line and thinking way back to your glory years, we are working with y equals mx plus b, where your b is your y-intercept and m is your slope. We live in the good old days. All right. Next definition I wanted to add in there was interpolation. Interpolation is using given data to approximate an answer found within the given graphed data. Okay, so basically find a point in your graph on the line of best fit. So it's basically being able to read your graph. Best fit. Extrapolation, the partner to interpolation. This is using a mathematical model developed from your data to create an equation to help predict values outside the collected data. So basically this means use your equation of line of best fit. All right, so you're just going to use your equation to see what would happen. Line of best fit. All right, there we go. So finishing off at the bottom here then. Regression. What is regression? Talked about it up above. It's a process, and it's a least square method is what it's called. And what it does is it estimates the equation for some given data. So before we just kind of plotted points in grade 9 and you hand drew in a line of best fit. Well, we have technology now that will take and allow you to plot data points like we did in scatter plots in grade 9. And then it will mathematically determine that line of best fit. Okay, so it will figure out that line of best fit mathematically for us. So how does that work mathematically? I'm not going to go into a ton of details here. I'm just going to give you a very quick overview. If you go into a statistics course, you're going to go into this in a lot more detail. I'm just going to show you the basics here. So the least squares method, it's used to determine the slope and y-intercept of the equation for the line of best fit. So again, we have a scatter plot. And here's the formula that is used, okay? So we're talking about y equals ax plus b, y equals mx plus b. A and b are interchangeable there in terms of m and b. So this is how a is calculated, all right? It takes the number of data points and it is the sum of x times y minus the sum of x multiplied by the sum of y, and so on and so forth. So this is something you're not going to do by hand. This is something that your computer or spreadsheet program is going to do. And essentially it is building a series of symmetrical squares, oops, and each of those squares, the data points are actually acting as the corner of the square. I'm just kind of making this up on the fly in terms of what it would look like, just to give you a general idea. And the general premise is that it creates a series of squares in which the line of best fit touches the corner of each square. Here, 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 obviously not drawn to scale. That's what the formula does, okay? So that's what your spreadsheet program is doing for you. We're not going to worry about the nuts and bolts here because my focus is on interpreting the data. Okay, so I'm going to leave it at that. So moving along then, we head into our first example here, and this is what I want you to be able to cope with or deal with. So the table shows data for the full-time employees of a small company. I want to answer the following. So create a scatter plot, determine the degree of correlation. So that's just last day's work. Determine an equation to model the data or the data. And that's easy because you already, the spreadsheet will produce that from parts A and B. So I'm going to slip over to the computer here. Not that you can tell the difference in time. And again, back here at the computer, we're going to go to Google Sheets. We're working on lesson 18. Again, if you go to the Google Classroom, those spreadsheets are pre-made for you. So I transferred this chart over to my spreadsheet program already. So the question was create a scatter plot with the data. So first thing I do, again, highlight. I want to insert chart. It never gives you the scatter plot, so you hit more, scatter, scatter, and now we have our scatter plot created. Now I'm going to go to customize and I can put my information in. So the topic here again was age versus income. We'll go with that for now. Got my legend, that's all right. Horizontal axes. I do want it to start at 0. And I am going to have it go up to, let's say 70. Seems to be around a nice number. Moving on to the vertical axes, I do want it to go through 0. And the max, let's go up to 60. Oh, it has it going up to 80, so we'll stick with the 80. That's fine. All right, so there's our chart. I can put my titles on. So vertical is income. Horizontal age. Very important to label the graph properly, especially when the computer will do it for you. Grid lines, not too worried about grid lines because we're not actually measuring off of it. And the last day we said linear, and I want an r² value or an r value. Remember, we've got to take the square root of that. So 0.97, so we have a pretty strong positive correlation between the data. So I'm going to stop there for a sec, and I'm going to go back to here, to my note, and I'm just going to make a note of that. So let's see, graph, B, a strong positive correlation between the data, and in brackets I'm going to put R equals, and I still got to figure that out because that's R squared, the 0.97. So I'm just going to use a calculator because I don't want to lose this page yet. I'm not done with it, so I don't want to hit insert quite yet. So we end up with, it turns out to be 0.98. So almost a perfect correlation right there. Now this is the new part for us, C part. Find the equation of the line, and this is how easy it is because this is what you've done already. I've just reviewed what you've done already. If you go down on your correlation here and pull down on label, you can go use equation and your equation shows up, or you can just put your cursor on top of the line of best fit, and I can see that it's 1.29x minus 4.6. All right, so there we go. So I can go back, y equals 1.29x minus 4.661, I think it was. So there is our model, all right, and where, always important, y represents the income and x represents the age. Okay, you need to identify those variables, and there we go. So that's the new part, C part. That's basically it. You are just reading off this graph. Now that I have that, I'm going to hit insert. It's all done and nice, and there we go. So I can return back and finish answering the questions here, and it says using your model. So I'm going to switch back to the smartboard. 1 second. All right, I'm at the smartboard. So number D then, if X is 21 years. If you want to use function notation for this, for people who are comfortable, you can write this as a function notation. So you could have said f of x equals 1.29x minus 4.61. Just makes it easier for the substitution. Doesn't matter in the end. So 1.29x minus 4.61, 1.29, 21, minus the 4.61. And from that, I just need a calculator. And my calculator tells me 22.5. So therefore, at 21, we expect an income of 22,500. Remember, this was originally income was in thousands of dollars. So you got to multiply that by 3. So that's I. The second part, it's just repeating it. So we're just changing our x value. So if x is 65 years, y equals 1.29 times 65 minus 4.61. Just extend that down a bit. Times 65 minus the 4.61. We get 79.24. So therefore, at 65, at this particular job, we expect an income of $79,240. And there we go. So really the only new stuff today, okay, is reading the equation off of your spreadsheet and then going back to grade 9 or advanced functions if you took that course and substituting in values. That's the only new step in the process. All right, that allows me to move on to the next example. So researchers monitor the number of wolves and rabbits, okay, and they think the wolf population depends on each other. So we're going to use the data to answer the following. So this is something that if you're going into ministry or wildlife and preservation, this is stuff that you would do. You'd be looking at statistics to determine trends in population growth within animals. All right. So again, create an appropriate scatter plot, determine the degree of correlation. So this is stuff from previous homework. And really C and D is the new stuff. So I'm going to move back over to the computer, so give me 1 second. Again, you can't tell time has passed. And ta-da, I'm back. Not that you can tell. All right, so I'm going to pull up my spreadsheet. So again, I've got these pre-entered, so we can go to example 2, and there is here rabbits and wolves. So this is a 6-year study from 94 to 2000. So we want to take a look at this information, and what they want us to do is create an appropriate scatter plot. So again, highlight the data you want, insert a chart, more, scatter, scatter, and then we can go and customize. So chart title would be, rabbit versus wolf populations. And scroll down, I'm on the horizontal, so the horizontal will be my wolf population. And a vertical would be rabbit. I guess it should be put in population, but that's all right. Again, I want to go from 0, 50 is fine. Horizontal, I like to see 0, 0 on my graph. Not that it's necessary. And we take that out to 100. All right, so there we go. There's our information there. So we've created a scatter plot technically. I'm not going to hit insert quite yet. So we got that done. Degree of correlation. Again, before I even look at it, I know that this is a strong positive correlation. So I'm just going to go back here and do some typing. So A, C graph, B, a strong positive correlation exists between rabbit and wolf populations. All right. I'm going to cut off the example here and finish up this one and another example in the next video. So I'll see you in a couple minutes.